Okay, so I am starting today with just a little bit of a talk about the Commons Height Lab. First of all, for my classes, I have pushed off the due date. I want to give you the weekend to work on it. So it is Monday. It's not going to have to all get done tonight. Now, to be honest, though, it'd probably be smartest to do it tonight because I'm going to be giving you some help with it right now. And then that'll fade fairly quickly. And then Sunday night, you'll curse yourself for not having done it Thursday night when it was fresh in your mind. Okay, so anyway, we'll be talking a little bit about the Commons Lab. I do not want to draw it all out for you, but I'm going to draw out one of the triangles just to show you kind of where we got this from. Now I'm going to do this, I'm going to try to do it with 3D type drawing. So I'm going to use that parallelogram I taught you how to make and make the base kind of look 3D-ish like this. There we go. Now the height of the Commons, of course, we're going to call H. And one of your angles was sighted like this, and I'm going to say it was 44 degrees. It was totally not 44 degrees. But there's a problem in your homework that is pretty much the Commons Lab. If you look it up, one of the last few days here of homework, there's a problem that has 44 and 55, and then a distance that you walk, between sightings is 50 meters. Okay, I've got that in my room. People on the video, I know you can't see this diagram in my room, but you can look for a homework problem that had two sightings, one at 44, one at 50, and then a 50-meter walk in between. Now, obviously, your numbers are different than that for the Commons, but they're the same setup. All right, so if it was as simple as this, I used H for the height of the Commons, and I used Z for that number there. I hope you can see that tangent of 44 would be H over Z. Does that make sense to you so far? So a lot of kids stop right there because they're like, that can't be right because I don't have a side in it. All I have is an angle. But if you have two variables and two equations, you'd be okay. So let's write another equation like that. But in the Commons Lab, you don't have that. What do you have? How many variables? 3. There's H, and there's Z, as you can set up and see in the classroom, and there's Y. So there's 3 variables. So there must be 3 equations. All right? That first and the second one are super easy. They're both just using tangent. Can you figure out the third one? All right? I'm going to give you some time right now to work with a partner, and you're going to try to piece together what those 3 equations would be. Okay, I am back with you after you've had a chance to think a bit. I hope from the drawing we have in class that you knew the other one was tangent 55. And would you guys finish that one for me? Over here, as you can see, it's 44 and 55, and this distance between them was 50. All right, so would you tell me the equation that has tangent of 55 in it, please? All right, well, you can't change variables on us. We have Z and H and Y. All right, so H over Y. All right, good. Now, I get that that isn't solved for anything. And I could either solve it for Y, or I could solve it for H. If I solve it for H, then that's good for putting into another equation, but you won't have H's at the end. So do you get you need to solve this one not for H, you want to solve that one for what? Z. And this one you want to solve not for H, you want to solve it for Y. And then you can put it in the other equation. What's the other equation? Well, this one stumps a lot of people because they're like, how much? I don't have any of the angles. I got a 90, but I don't know any of the angles. How am I supposed to write a tangent or a cosine or whatever? You can't. What can you write, though? You can write an equation, it just doesn't have any angles in it. What do you think? You got it. So it's just that squared plus that squared makes that squared. That's your third equation. That's the triangle that's like laying on the floor up here. It's got the 50 and the Z and the Y. And if you truly turned at a right angle and walked down the hall of the commons, then you know it's a right triangle with a y and a z and a 50. So again, you've got y squared plus 50 squared would equal z squared. Then you've got three equations and three variables. And from there, you want to solve it all down so you have only one equation. And ideally, that one equation will only have h's in it. But if that's too confusing for you, well, then solve for y first. And now as soon as you know y, you'll have a triangle that's got a side and an angle, and then you can figure out h pretty easy after that. So it really isn't that big of a deal if you can't make the equation only have h's in it, but then you have to make the equation only have y's in it, or only have z's in it. All right. So again, I'm trying to help you, but not help you too much. So this is the part where I'm going to stop and say, okay, from there, if you're still having trouble with this, there is a homework problem that you can find that has an answer key. And it's a lot like the commons problem. And it's got 55 and 44 and 50, just numbers we just used in class right now. That was basically a setup of that homework problem. So that also could be handy in solving the commons lab problem. I know some people are going to be at the end, I got this equation, but I don't know how to solve it. At worst case scenario, what method have I told you like 10 million times would always work for solving equations if you were allowed to do it? Graphing. Graph both sides, see where they cross. That's always allowed. Not saying it's easy to read because your normal window only goes to 10 and 10, and we got big numbers in here like 50, and the commons is huge numbers, right? The height of the commons is pretty tall. So you're going to have to expand your graph a lot to be able to see where those lines cross. But otherwise, if you don't do it with graph both sides and see where they cross, you'll have a lot of solving to do with like square roots of things that are being squared, but it can be done. All right, the Commons Lab is due on Monday. All right, next step, I want to talk to you briefly about, I'm going to pause for a second. Okay, I'm going to talk to you about the law of, which one should we use on this, by the way? Why shouldn't I use the law of sines? Because it is easier. Law of sines is better because it's easier. Exactly. We've got the side angle sandwich, or side angle side. If we had the side across from an angle, that's when law of sines would be good. This one is all set up for law of cosines. And by the way, if I hadn't, in fact, if I had it do over again, I actually would not have a letter there, because then you should know that. What is the default for the angle they give you? You got to make it C. Okay, go ahead, solve this one together with your partner. Should be easy. I'll pause for a second. You'll need a calculator for sure. Okay, in case you're super stuck, a squared plus b squared minus, who has it memorized? 2ab sine c, right? No, it's the law of cosines. Cosine c. All right. I don't get that. Okay, there we go. Equals c squared. Don't forget it equals c squared. So you get a really big number at the end. You got to remember it. Oh, that's right. Got square root at the end of this. Okay. So I hope you've gotten it. Raise your hand if your group has an answer. Pretty much everybody in the room has one. If you just simply put all the numbers in that I told you. But wait a minute. You never told us which one A and B were. It doesn't matter. As long as this one's C, if this is an 8 and this is a 9, or if I reverse them, I'm just still going to square them and add them. It doesn't matter. Or if this is an 8 and this is a 9, or I reverse them, it won't matter. All said and done, you get 4.5 approximately. Raise your hand if you had that one right. All right. Okay, so if this was 4.5 and I asked you to find that angle there, I'm not going to actually, but if I did, you could solve it through some complicated use of the law of cosines, but I don't recommend it. Instead, use the law of sines. All right. Because now I got a side and an angle across from it. So that brings us to a challenging question. The top one here, not challenging. Easy, super easy. Find that one, go ahead. The bottom one, I think, is going to freak you out a little bit, but first we'll do the top one. Find the green side if this were to be a perfect right triangle. I'll pause while you do that. Okay. Could you use the law of sines? Yeah, I suppose you probably could, but or the law of cosines, maybe. But I wouldn't even be thinking that way. I'd be just thinking sine of 22 is equal to opposite over hypotenuse. Question mark over 8. So it's 8 times the sine of 22, right? What did you get for that one, Mr. WR? 3. Raise your hand if you had 3. All right, good. But it's not 3. Because down here, I decided that I was going to make it 7. But I know this is going to kind of freak you out a little bit, how it all works out. So I'm going to do something to preface this. I know that the angle in this triangle is 22. But imagine for just a moment that it was 30. Okay? And since we're doing law of sines, because we have a side and the angle opposite from that side, law of sines is appropriate, right? So let's just play with sine for a minute. Everybody grab your calculator and type in sine of 0. What is sine of 0? 0. And if I were to make a little picture of what happens here, sine of 0 is 0. Gentlemen, you're talking right now, which is not good. You either stay with me or leave. All right. So sine of 0 was 0. And now I'm going to ask you to do, what's sine of 30 degrees? 0.5. So at 30 degrees, it goes up to a half. And here, let's say that's 1. Okay. How about sine of 90 degrees? It hit 1. Do you know what sine does? It oscillates back and forth. Let's go past sine of 90. Let's go to sine of 120. Sine of 120, what'd you get? 0.8? 0.8, okay. So it's somewhere a little less than 1, all right? Let's go to sine of 150. 0.5 again. Interesting. Do you get, this thing is making a curve. It's going up and then back down again. It's not actually. It's not going in a straight line. But if we connected a whole bunch of little dots, you would see that this thing rises till it hits 1, and then it falls all the way until it hits 0. What do you think the number of degrees will be when sine hits 0? 180. Try 180. Sine of 180. What is it? Okay. So, do you get that sine of 30 and sine of 150 came out exactly the same? Does that make sense to you? All right. Then, I think when you do this next problem here, when you figure out this angle here, which is clearly an obtuse angle, I think it's going to freak you out a little bit because you're going to be like, what? That doesn't make any sense. But what I just told you, hopefully will help it to make sense. I'm asking you to figure out how far is this base right here. And, of course, this could have swung the other way. I hope by now you've figured out that we've got an ambiguous case situation there where I could have swung my 7 out the other way. So what's the base if it's short like this, and then what's the base if it's this huge long distance here? Find the two possibilities. Well, just do them one at a time, and I'm telling you, start by finding that little blue angle, and then notice something. All right. I'm going to pause while you try to find the two bases that you could have. We have practiced this before. We've done this problem before. But this one has a special weird little twist to it. All right. I'm going to pause while you figure that out. Okay, just to clarify, I hope you solved for the blue little theta there, and then the setup would go like this for the people that are struggling. Sine of theta and 8 go together, right? So I go 8 over sine of theta. And the 22 and the 7 go together, right? So 7 over sine 22. The weird thing is when you solve that, you get theta is some small number like 25. What was it? Yeah, 25 point something? 25.3. So if that's 25.3 degrees, I am a monkey's uncle, because that does not look like 25 degrees. It looks way bigger than 90. So you can't just say like, oh, well, I'm going to go with it being 25 because that's what the calculator said. No. Did you then figure out that this other angle would theoretically have to be 150, what was it? 154.7 or something like that? Okay. And do you get that what's really happening is you're figuring out that 154.7 or 25.3 would both give you the same thing? If you haven't tried that yet, sine of 25.3 or sine of 154.7 come out the exact same. It's the point of this is an ambiguous case. You can't tell what this angle is, so you have to think it through and say, okay, it must be this one is 25.3. And the other one must be 154.7. And this must be 25.3 again, because that and that are the same. If you haven't already made that leap, I needed to get you that far, so that now you can figure out how long is the red part, the shorter base that this triangle could be, or how long is this green part, which is the longer option. Figure out the final answer, and we'll see which groups are able to pull it off. How many of you did have that? You knew that. All right, so a few of your groups kind of caught what I was laying down there. Pausing. So we figured out that the longest one here, the big green distance, was 13.7-ish. Again, within rounding, maybe 13.75. And the other one, the shorter guy here, is like 1.09, something like that. Okay, good. And the main idea would be try to find this angle. Knowing these two, you can find the third angle really easy. And from there, you can find this part right here really quick by using law of sines. Okay, moving on. Let's look at the homework together here. It is day 2 of, I'm going to pause while I find it. There we go. It's day 2 of law of cosines. And I am allowing people to skip number 13 on this front page. If you find number 11 to be annoying and you'd rather do 13, I can live with that. I just want you to do one of those. And then number 20 has got a nicely set up little word problem. Don't trust that those helicopters are for sure in the right spots to give you the right angles. It's just trying to show you a triangle using bearings. If you're not good at bearings, I know some people really had trouble with this. You can talk to me about what the heck does a bearing of north 8 degrees east mean. All right. Then this one, last problem, is, and don't worry about the golf hole problems. We will talk about those in class on a different day. This one is, again, a bearings thing. So you can see there's a lot of bearings problems again. See, if you weren't ever good at that, we should talk. Make sure you get good at that. All right, so that's your last one for your homework for tonight. So basically 2 word problems and 1 law of cosines. It's very doable, so I'm keeping them reasonable. You guys keep getting them done. Any last questions to clarify on this? All right, that's all I got for you for today.